Hello everyone. In this lecture, we are gonna study the engine systems. So I'm gonna present a brief explanation of the systems that help an engine to run and keep running. We'll start right now with the lubrication system. The moving parts of an engine need constant lubrication. Lubrication limits the amount of wear and reduces the amount of friction in the engine. Friction is heat generated when two objects rub against each other. Motor or engine oil is the fluid used to lubricate the engine. Several quarts of oil are stored in an oil pan bolted to the bottom of the engine block. The oil pan is also called the crankcase or oil sump. When the engine is running, an oil pump draws oil from the pan and forces it through oil galleries. These galleries are small passageways that direct the oil to the moving parts of the engine. Oil from the pan passes through an oil filter before moving through the engine. The filter removes dirt and metal particles from the oil. Premature wear and damage to parts can result from dirt in the oil. Regular replacement of the oil filter and oil is an important step in a preventive maintenance program. Also, we have another system, which is the cooling system. The burning of the air-fuel mixture in combustion chambers of the engine produces large amount of heat. This heat must not be allowed to build up and must be reduced, and this heat can easily damage and wrap the middle part of an engine. So to prevent this, engines have a cooling system. The most common way to cool an engine is to circulate a liquid coolant through passages in the engine block and cylinder head. An engine can also be cooled by passing air over and around the engine. Few air-cooled engines are used in automobiles today because it's very difficult to maintain a constant temperature at the cylinders. If the engine is kept at a constant temperature, it will run more efficiently. A typical cooling system relies on a water pump, which circulates the coolant through the system. The pump is typically driven by the engine. The coolant is a mixture of water and antifreeze. The coolant is pushed through passages called water jackets in the cylinder block and head to remove heat from the area around the cylinders, combustion chambers. The heat picked up by the coolant is sent to the radiator. Radiator transfers the coolant's heat to the outside air as the coolant flows through its tubes. To help remove the heat from the coolant, a cooling fan is used to pull cool outside air through the fins of the radiator. Also, to raise the boiling point of the cooling system is pressurized to maintain this pressure. A radiator or a pressure cap is fitted to the radiator. A thermostat is used to block off circulation in the system until a preset temperature is reached. This allows the engines to warm up faster, and the thermostat also keeps the engine temperature at a predetermined level because part of the cooling system are located in various spots under the vehicle's hood. Hoses are used to connect these parts and keep the system sealed. Also, another system that we have is the fuel and air system. The fuel and air system is designed to supply the correct amount of fuel mixed with the correct amount of air to the cylinders of the engine. This system also stores the fuel for later use, delivers the fuel to a device that will control the amount of fuel going to the engine, collects and cleans the outside air, delivers outside air to the individual cylinders, and changes the fuel and air ratios to meet the needs of the engine during different operating conditions. The fuel system is made up of different parts. A fuel tank stores the liquid gasoline. Fuel lines carry the liquid from the tank to the other parts of the system. A pump moves the gasoline from the tank through the lines. A filter removes dirt and other particles from the fuel. A fuel pressure regulator keeps the pressure below a specified level. An air filter cleans the outside air before it's delivered to the cylinders. Fuel injectors mix the fuel with the air for delivery to the cylinders or directly to the cylinders, and an intake manifold directs the air to each of the cylinders. Another important system is the emission control system. Engines have been engineered in modern day to emit very low amounts of certain pollutants. The pollutants that have been drastically reduced are hydrocarbons, carbon monoxide, and oxides of nitrogen. The Environmental Protection Agency establishes emission standards that limit the amount of these pollutants a vehicle can emit. So to meet these standards, many changes have been made to the engine itself. There also have been systems developed and added to the engine to reduce the pollutants they emit. So we'll mention some of these systems. We have the positive crankcase ventilation, PCV system. This system reduces hydrocarbon emissions by drawing fuel and oil vapors from the crankcase and sends them into the intake manifold, where they are delivered to and burned in the cylinders. This system prevents the pressurized vapor from escaping the engine and entering into the atmosphere. Also, we have the evaporative emission control system. This system reduces hydrocarbon emissions by drawing fuel vapors from the fuel system and releases them into the intake air to be burned. This system stops these vapors from leaking into the atmosphere. Also, there is another system which is the exhaust gas recirculation, EGR system. This system introduces exhaust gases into the intake air to reduce the temperatures reached during combustion. This reduces the chances of forming nitrogen oxide during combustion. Also, we have the catalytic converter. Located in the exhaust system, it allows for the burning or converting of hydrocarbon or carbon oxide and nitrogen oxide into harmless substances such as water. Also, we have the air injection system. This system reduces hydrocarbon emissions by introducing fresh air into the exhaust system to cause minor combustion of the hydrocarbon in the engine's exhaust. So let's move and discuss the exhaust system. During the exhaust stroke, the engine's piston moves up and pushes the burned air-fuel mixture or exhaust out of the combustion chamber into the exhaust manifold. From the manifold, the gases travel through the other part of the exhaust system until they are expelled into the atmosphere. The exhaust system is designed to direct toxic exhaust fumes away from the passenger compartment to quiet the sound of the exhaust pulses and to burn or catalyze pollutants in the exhaust. A typical exhaust system contains the following components: exhaust manifold and gasket, exhaust pipe, seal and connector pipe, intermediate pipes, catalytic converter, muffler and resonator, and tailpipe, heat shields, clamps, gaskets, and hangers. Let's move right now to the electrical and electronic systems. Automobiles have many circuits that carry electrical current from the battery to individual components. The total electrical system includes such major subsystems as the ignition system and the starting system, charging system, and the lighting and other electrical systems. And let's start with the ignition system. After the air-fuel mixture has been delivered to the cylinder and compressed by the piston, it must be ignited. A gasoline engine uses an electrical spark to ignite the mixture. Generating this spark is the role of the ignition system. The ignition coil generates the electricity that creates this spark. The coil transforms the low voltage of the battery into a burst of 30,000 to 100,000 volts. This burst is what ignites the mixture. The mixture must be ignited at the proper time in order to complete combustion to occur, although the exact proper time varies with engine design. Ignition must occur at a point before the piston has completed its compression stroke. On most engines, the motion of the piston and the rotation of the crankshaft are monitored by a crankshaft piston sensor. The sensor electronically tracks the piston of the crankshaft and relays that information to an ignition control module. Based on input from the crankshaft piston sensor, and in some systems the electronic engine control, the computer, the ignition control module then turns the battery current to the coil on and off at just the precise time so that voltage surge arrives at the cylinder at the right time. The voltage surge from the coil must be distributed to the correct cylinder because only one cylinder is fired at a time. In earlier systems, this was the job of the distributor. A distributor is driven by a gear on the camshaft at 1/2 of the crankshaft speed. It transfers the high voltage surge from the coil to spark plug wires in the correct firing order. The spark plug wires then delivers the high voltage to the spark plugs, which are screwed into the cylinder head. The voltage jumps across a space between the two electrodes on the end of each spark plug and causes a spark. This spark ignites the air-fuel mixture. Today's ignition systems do not use a distributor. Instead, these systems have several ignition coils, one for each spark plug or pair for spark plugs. When a coil is activated by electronic control module, high voltage is sent through a spark plug circuit. The electronic control module has total control of the timing and distribution of the spark producing voltage to the various cylinders.